Hi, I'm Travis and I'm an engineer on the academic team here at National Instruments. And today I want to show you a new approach to teaching physiology concepts in a way that's tailored to engineering students. Let's use physiology, specifically heart rate and blood pressure, as our focus. We know that studying the circulatory system is essential for any engineering student looking to work in the biomedical field. However, traditional laboratory experiences may have students working with analog medical equipment such as a stethoscope or other traditional medical tools. Now, while experience with this equipment is great for students going into the medical profession, it misses the point for engineering students. Instead, we can show engineering students how to work with engineering tools while learning physiology concepts. Introducing a student to concepts such as systolic and diastolic blood pressure and QRX complexes, while at the same time introducing them to signal conditioning and analysis concepts, is a more effective way for them to learn about physiology because it's in a relevant context such as engineering. So I'm going to walk through a specific example of teaching students about exercise physiology using an engineering system. We'll measure heart rate and blood pressure of a subject at rest and then during exercise and compare these values to their calculated target heart rate. So let's get started. An important part of this process is the engineering student actually understanding what the system is doing and its parts. So here I have a blood pressure cuff hooked up to a pressure sensor, a pulse sensor, and both of these signals are being run into my measurement system. In this case, we're using a MIDAC. To start my experiment, I'm going to need a test subject. Now what we have to do is hook the blood pressure cuff up to his arm and the pulse sensor to his finger, and we can start taking some data. So the two signals that we're acquiring are going into our virtual instrument written in LabVIEW. Now we can see that our test subject still has a pulse. Now if I increase the pressure in the cuff, we'll slowly start seeing our pulse disappear. At the moment that our pulse disappears, we can call that the systolic pressure. Now if I slowly release the pressure in the cuff, the moment that we see our pulse reappear and stabilize, we call that our mean arterial pressure. And with a little bit of math, we can calculate our diastolic pressure. So now our test subject is going to go work out, and then we're going to take the same measurements when he gets back. Now that he's back, we're going to go ahead and take the same measurements and make some comparisons. Well, it looks like that pulse is a bit higher than it was before, and he's still alive. Let's check that blood pressure. It looks like our blood pressure actually stays the same. Thanks, Dan. So you can start to see that teaching engineering students physiology concepts using engineering tools helps make the content more relevant. To further explore this approach, download the free courseware linked on this page.